Hey guys, I'm Catherine, and welcome to part 2 of this strings interview questions series. And today we're going to talk more about instance methods. We're going to talk more about, things that will help you solve interview questions. And so I'm going to go ahead and open up Sublime. And here we are, we have our Sublime open. I'm going to make the text a little bit bigger so you can see it. And so we're just going to create like a class. It's going to be called string part 2, because it's the part 2 of this part, and then we're going to open and close those curly brackets, and we're going to save this in our desktop, and we are going to call it string part 2, dot, and then Java, because we're going to code this in Java. There we are. And then the first thing we do is a main, and you can just type main and then hit enter, and then voila, you have this great thing for us. And so most of our code is going to be in the main today. We're not focusing on classes, mainly just, more instance methods. And so one instance method is compareTo, and we didn't talk about this one last time. And basically what it is you're comparing strings. And so this compareTo method, it returns an int, and it takes a string s, whatever string you want it to be, and if it returns 0, it means that the two strings are equal. If it returns a positive number, then it means that the first item was greater, and so the first item was greater. And if it returns a negative, then it means the second item was greater. And so that's kind of what this is doing. And so let's just, jump into some examples, see what happens like we usually do. And so we're just going to create a string, and it is going to be called hi there. Very similar to last time, you have the string, and we're going to go hi there, and we'll have an exclamation point there, and then our semicolon, all is good. And so let's do some print statements, and we'll go system.out.println, and we're going to print out hi there dot compareTo, and what if we lowercased that first h? What if we did hi there with them like all lowercase, but we still had that exclamation point? What would happen? Like, they're similar, but are they the same? Well, we will find out. And so basically, if they're the same, then this will be 0, and if it's any other number than 0, then they're not equal. Another thing you can do is you could go hi there dot compareTo, and we can try it, exactly the same. Will these actually match up? We'll see what happens there, and then we'll also check what happens if we use instead of like up here we did the literal, what if we did new string using the new operator, and in here we put hi there, as usual. So what if we use the new operator versus the literal? Will they still be the same? And then we can also go system.out.println hi there dot compareTo, and then hi there. Those should be equal, right? What is life? Like, if those aren't equal, then like what? We don't even know what's going on. And so I'm going to open my terminal here, and we can make this nice and big. And here we are. And we're going to cd into our desktop because that's where I have this thing saved. And the first thing we're going to do is Command B to build this application, and it's going to build, and it's all good. And then we're going to go Java string part 2, and this is going to run our application in the terminal. Here we go. So we had they're not equal, they're equal, equal, equal. And so here, if we lowercase the h, it's not going to be equal to this hi there, so case does matter here. But what if we did, dot to lowercase? Do you remember that method from last time? And so what if we had this? If we took this all to lowercase and then compared it to this, would it still be the same? We're going to build that, go up and run it. Now everything's the same. So it doesn't matter if you use the literal or the new operator, it's still going to be equal to the original hi there. Hi there obviously equals hi there, and if you do the two lowercase here, then they will be equal. Does that make sense? And because the lowercase returns a new object, it doesn't mutate a string because a string is immutable, then these like lower lines work because the capital H will still be in the original hi there, because two lowercase doesn't mutate the original hi there string. Cool, okay. Another way we could do this is we could take away, or actually we'll copy and paste this thing. There we go. And instead of doing two lowercase, you could do dot compareTo ignore case, and that will ignore, except we forgot things. We have errors, and that's because okay. And so if we do compare to ignore a case, then it's going to ignore the case of the thing. And so we built, and again, it still works. So that's another way you could do these two, kind of do the same thing, these two. Another thing that we can do with strings is we can split them. And so this is actually a super important method. I've used it in many technical interviews, and so remember this method if you remember anything today. And what it does, it returns a string, an array of strings, and it's called split. And you give it a string that happens to be a pattern. And so here we have regex, and basically what that means, it means regular expression, but that's a whole other story of things, but just think of it as a pattern. And so we can put a pattern in here that we want to split our string on. And so one pattern is like a space. So say I want to split the string on the spaces. And so each token from that string would then go in this array. This is really abstract and we don't really know what it means. And so we're going to just code it and see what happens like usual. And so we are going to go string story, and we're just going to create the story here, and it's going to be called She Goes to the Store. You know, simple, cool, chill. She goes to the store. That's our story. And so what we want to do is we want to split it on the spaces. And so say we have an interview question that's like, how many words are in this document? That could be a question. And so the way we could use split is we could say string array word list equals split. Nope. Equals story dot split. And we want to split on the spaces. So now every, like, she is going to be one, object in this array. Goes is going to be a string that's in this array. To is going to be a string that's in this array. So we'll split all of that. And then we could print out our word list and we could see what happens. And now this probably won't work because of addressing, and that's annoying, but we'll see what happens here. Yeah, so here it printed out an address. It didn't actually print out our word list. And so we are going to do a for loop super quickly, and it's just going to go from I to the word list dot length, and we're going to increase that I. And when we do this, we're going to just print out the word list, and we're going to print out whatever is at that index I. And then at the very end, we are just going to do a system.out.println. And we're actually going to do a print here so that they're all on the same thing. They're all on the same line. So we'll build that and we'll see what happens. And so here we have she goes to the store. And we could actually see, if we do a little, there we go. Okay. We could actually see how many tokens there are. So she is a token, goes is a token, to is a token, the is a token, and store is a token. And because we ended with this last thing, there's only 5 tokens. And so if we print out, if we print out system.out, and then we go word list dot length, we build it. And then we see what happens here. We have 5. And notice there's 5, words inside of this story. And if I added more words, I could do that. But the thing is we define a word as something that's separated by a space. And so how many words are in this document? Well, you could split on the spaces and then see how many words are going to be in the word list after we split on the spaces and we put each token, as you could say, inside of this string, array. What if you added, commas? Or what if you had, there's a lot of other punctuation things, like a semicolon. Like, does that count as part of the, there are other things that can separate stuff, and do you want to take those out and stuff like that? There are other ways to separate things. Like, what if you had, webmaster? Would you want these to be 2 different words? Do you want to consider that? Or do you want this to be 1 word? There are other things to consider when you're trying to figure out how many words are in a given document. And then those would be the important questions to ask during your interview. What defines a word? That's important. Understanding your problem is important. And you could also do this with substrings and with the characters to find out how many of a given thing are in my, document. It may be a little off because of the way it's split, but it would be a close estimate. Another method that we can do is called starts with. And so if we do Boolean starts with, and we have the string that's going to be our prefix. And we have this prefix, and basically what we can do is we can say like, hey, I'm going to give you a string, and if it starts with the given prefix here, then you're going to return back true. If it doesn't, then you're going to return back false. And so let's use this in an example and see what happens here. If we have this string called shells, and in the string, we are going to say Sean sells seashells at the seashore. That is our string. It is great. And so here we're going to say, like, does it start with a given thing? And so we could say system.out.println does shells dot starts with, and we could say se. Does it start with that? And it kind of starts with that. Will this matter? Let's see, false. We get false because we didn't capitalize the S. And so if we capitalize the S, we get true. And so understanding the uppercase, lowercase, making sure your cases match is super important, especially when you're dealing with like string analysis, string manipulation, and stuff like that. And so another way we could do this is if we add some enters to separate some stuff out here. And let's put this more in the middle of the page. There we go. And so a way, like this may not seem super important right now, but we could actually combine it with the word list to make something really cool. So you could say like given a document, how many of these words start with this prefix? We have this kind of, function here that will run throughout the program, and we'll need to test for each word, does it start with this given prefix? And we can use split to split it up into those word tokens that we can then test, does it start with this, does it start with this, does it start with this, etc. And so we could say the question is, how many words in a given document start with SE? There you go. That's a thing. And so here we have SE, SE, SE. And so a good question to ask your interviewer would be like, what is a word? Like for the last one, like are words separated only with spaces, or do you have semicolons? Like is there a way that two words can be separated that are not, by a given space? And so again, if you have webmaster, or if you had seashore, is that considered one word? Or if you had like a comma and stuff, and then you may have to further go into the thing and say, hey, I consider, like if it was Sean sells seashells, and then it has a comma, and then at the seashore, like would your interviewer want you to take out this comma later on? Like understanding that and understanding what the word is and what you need to get these, things down to is important. And so let's just jump into this code and see what happens. And so what we'll want to do first is we'll say that a word is always split on these spaces. And so we'll say string, we'll say, word list 2, or we'll call it shell list, shell list equals, and then we'll do shells dot, and then we'll go dot split, and we'll split on the spaces. And so one thing to keep in mind here is you probably at some point, if you're analyzing text, is you're going to want to go all uppercase or all lowercase. And so for your first rule, I guess, whenever you're given like a string problem, you'll want to lowercase everything. So everything's in the same case, so we don't get the problem that we did up here with, this. You'd rather just completely everything be the same case, so that way you can be like, hey, can I run statistics on this, given piece of text? And so say everything is lowercase, and so we'll go dot to lowercase for reasons that we saw before. And the reason we have to have parentheses around this is because like Java analyzes stuff from the right to the left, and we want this portion to happen first, and so we want to put parentheses around it saying, hey, take shells to lowercase before we split it. Okay, so now that we have everything in lowercase, we are going to want to have this int count, and we'll start it off at 0, and we want to count out how many words start with this, beginning say. And because we have this in lowercase, Sean will still be in this thing. And so I'm going to do a different type of for loop here. If we go for string s in our shell list, we are going to do some stuff. And so what are we going to do? Well, we want to test if it starts with this given say. And so if we go if, our string s dot starts with, and we'll start it off, does it start with this? then we want to increment our count. And so we'll go count plus plus. Awesome. And then otherwise, we don't want to increment the counts because it didn't start with that thing. And so there we go. And then at the very end, we'll want to print that count. And so then we can see how many, things started with, say. And so let's build this. Let's see what happens. No errors syntactically. Yay. And so here we have 4. And so that's a 1, 2, 3, 4. Yeah. So we got it. We got it correct. We went through and we split on the spaces, and then we went through each token to then figure out how many started with the say. Awesome. Okay, next method. Cool. And we'll actually do this. Oh, and I was doing a list here. Why was I doing a list? Okay, so you'll want to lowercase everything. If you're given, say you're given a string problem, usually the things you want to worry about are casing. You want to make sure everything's in the same case. You're probably going to somehow split the things. You're going to need to be able to say, hey, I need to split it into these tokens to figure out, okay, what am I working with, what words I have, and then from that split, then you'll take out the commas or you'll take out other extraneous, things, and you'll analyze the text that you have. And then sometimes you can actually write patterns. Like here we just did split because or split space because that's what we did. But you could also do, commas and other stuff. And then if it's a comma, then disregard the token or something like that. There's a lot of other things that you can do. And so then the third step would to be analyze and figure out what you need to do with that given piece of text. And sometimes that will include hash maps and arrays and a bunch of other things that you will do later, and we will talk about linked list queues. You might need to use those, but that's for later. This is just the beginning of how we're doing stuff with strings. And so another method that we can do with strings is we can trim them. And so we can go string trim, super chill. And what this does is it takes off the space on the right end and the left end. And so if I have the string, if I go to the movies and I say, I am going to the movies, we'll add a lot of space. What trim will do is it'll trim off the ends. And so if I go system.out.println and movies.trim, there we go, we'll build that. I'm going to the movies, and you can't see if there's extra space on the end, but if I do this, there's no extra space at the front. So what if I did a B here? What would happen? Well, we're still going to have that extra space because it's not on the ends. If I actually save that, and if we print out the original, I think this will make more sense too. Movies. Okay, so here we have the original, which is this, where we have all this space at the beginning and all of this space, leading and trailing space at the end. Actually, we don't have any at the end, but we can add some. Save, build. There we go. And we'll have all of this space at the end too. There's space at the ends and at the beginnings, and when we do the trim, it takes that away. But it does not take away the inner space. It doesn't take away this inner space right here. So how do we get rid of that? Well, you do other things. You do other things that are important. And so what we can do is we can go string cleaned equals movies dot replace all, and we are going to replace //s with a space. And so what this means is this is actually a pattern. It's saying I want to replace all of the spaces, new lines, tabs, anything that's going to cause a break within my text. I want to replace all of that with just a space. So it's going to replace each space with just a space. And if we wanted to replace all of this with a space, then we can do plus. And what the plus means is that for one or more of these spaces, new lines, tabs, I'm going to replace it with just a space. And so this whole thing will be replaced with just one space. And then this thing here will be replaced with just one space. And so if we add a semicolon there, and then we print out cleaned, build that, and then run it, here we go. We have a space at the beginning, which we can get rid of if we want to, but for this exercise we won't. And at the end, here, everything, all of the in the middle spaces, the inner spaces are gone. And so The trim gets rid of the outer spaces, and then this method gets rid of the inner spaces. Again, trimming your input text, making it better, making it cleaner, and stuff like that. Super helpful when you're getting these interview questions. The last method I'm going to show you today is actually a static method. And so if we write this all out, we'll go static, and it's actually going to return a string, and it's going to be a value of a primitive X. And so primitive isn't a data type, but this can be used on any primitive type. And one thing I should mention is that this is static and everything else we've been doing is instance. And just a super quick review, to use, compare to, split, starts with, trim, you have to actually have a string. You have to have a movies, you have to have a shell, or else you can't trim it. You can't, get the length of it. You can't do these other instance methods on it because there is no instance to do it on. Like, what would you trim? What would you, split? What would you compare? There's nothing. But for a static method, you don't have to create a string to use it. You can just go string dot, whatever it is. You have to type out the word, but you don't actually have to create a new object. And so what is this value of? Basically, we give it like an int, a character, or a Boolean, and from that it converts it to a string. So let's just look at some examples. If we do like string num equals string dot value of, and we give it 5, what it'll do is it'll convert 5 into a string. And if we do the same thing for a character, if we go string dot value of a, there you go, that's a character. It'll convert this character into a string. And if we go string bool equals string dot value of, and we have to do value of here as well, value of, and we put in, true. It'll convert true into a string. And so if you print all of these out, num system dot print ln character, and then system.out.println boolean, or just bool, and we build it, and then we run it. We'll get these here in the console. And you might be thinking, well, I could just type 5 here, build it, and then put it in here, and it's still going to be 5. Like, it's not going to change. And yeah, I could see that. You don't really see the value of this value of method, but what it really comes in handy for is when you are accepting, user input. So say you ask the user, hey, input a number between 1 and 10, and I'll guess what it is. And of course, you as the programmer can like save it and then just return it, but they don't know that. But say you wanted to get like an integer from the user, like what the user gave you, like was meaningful in the program. What we could do is we could say integer user int equals integer dot value of num. And so here our num was 5. And so this is kind of the opposite of what we did before. So what I can do is I can get user input as a string, and then I can convert it to an integer so that I could do math with it. I could do like user int plus 10 equals, does it, or like if user int plus 10 does not equal 0, then something bad happens or whatever. Like, you can actually use this number in your program, and the same goes for Booleans and characters as well. We could go Boolean, we could do user bool, and we could go Boolean dot value of, and we could put this bool in here, and then we could do characters a little bit different. You would do character C equals, and you would just do, like, say we want to use character dot, and then we would do char at 0. So it's a little wonky and different, and actually really intuitive if you think about it, but if you're just thinking of the value of, there is no character dot value of, because you can't, do that, but you can get the character at 0, and that will give you the one character that was returned by the user. And so this is where it really comes in handy. And so this would be important to remember if you need to get input from the user. So what are other questions that might be asked in your interviews about strings? Well, what about find the first non-repeated character in a string? What about that? Well, we can't really solve that yet. we can't really do much except count things, trim things, do things with our strings, but we can't actually save a lot of data because we haven't learned about data structures yet. We haven't learned about our queues, our stacks, our hash maps, our linked lists. We haven't done that yet. And so that will be what's coming up next. And so if you have any good practice interview questions, feel free to comment them down below, and I will see you next Friday.